Okay, quiet please. So the question I had up was solve, and then number 1 was 3, 4 to the x plus 1 equals 7. When I see an exponential question and it says to solve, I am first going to look if I can make common base. Right? That's the very first thing I'm going to do. Right now, I can't. Then I'm going to say, okay, I'm going to convert it to a log, or I have to get it into some form. Now I say, if I have this 3 in front, I can divide it over if and only if the 7 does not have an exponent. Does the 7 have an exponent? No. If the 7 had an exponent, I would have to log base 10 both sides. I would have no options. So I can divide the 3 over because the 7 does not have an exponent. But if the 7 had an exponent like this 5 has an exponent, the only way I'm going to be able to solve it when there's 2 exponents not common base is log base 10 both sides. You have to see and know what to do. That's going to be the hardest part. So I see an exponential, and the first thing I do is I check, can I do common base? No. Okay, can I divide the 3 over? Yes. If I can divide the 3 over, I can convert to a log. All right. So I'm going to have 4 to the x plus 1 equals 7/3. Now, 1, 2, 3 pieces of information. If I have 3 pieces of information, I can convert to a log every single time. So I go log, base of my exponent becomes the base of my log, which is a 4. Again, wow, I really base forward for a while. And then we're going to have 7/3 beside it, because what's with it doesn't stay with it, and always equals the exponent. And the reason why it equals the exponent is because so that exponent can drop down, correct? Now, we go log base 4 of 7/3 equals x minus 1. Log base 4 of 7/3 minus 1 equals x. And then I type that in and I get what? Is the shower going on in the corner? I can't hear you. Can you not hear it? Sounds like a shower is running on top of my roof. Yeah, if there's not, I don't know what it is. You know, trade-off. Yep, 0 plus. So 3, 9. We'll go to 2. Okay, we agree? Now, we can y1, y2 this. We y1, y2 the question that was given to you, the typed version, before you touch it, correct? y1, y2, find out where they intersect. It should match. If it doesn't match, make sure you typed it into your calculator, right? Because some people will type it in wrong, and then they'll try and figure out what they errored in algebra, and they didn't. It's in your calculator typing. So make sure you typed it in correct. Second trace 5, enter, enter, enter. Every solving question in this unit, you should y1, y2 and check, and walk away, knowing you got it or not. Okay, 2. I have 9 to the x plus 1 times 3, and then I'm going to put that to the 1, always when 1's sitting by itself. And then 81 to the 2x minus 1 equals 27 to the 2x plus 1. It's a solving exponential. And honestly, if I see this, I'm praying that I can do common base. Because if I have to log base 10 both sides, that's going to really suck. Because I'm going to have to go log base 10 of 9 plus log base 10 of 3 plus log base 10, or minus log base 10 of 81, which could happen. So I'm hoping that this is common base, which it is. So exponentials, we always check for common base first. We can make them all be base 3. 9 is 3 squared to the x plus 1. And then 3 to the 1. And then 3 to the 4. The 2x minus 1. And then 3 to the 3. To the 2x plus 1. And so I get 3 to the 2x plus 2. 3 to the 1 over 3 to the 8x minus 4 equals 3 to the 6x plus 3. Now, the left side has to get all put together before I can even drop the exponents down, right? Because I have to have 3 to the something equals 3 to the something before I can say the exponent's equal. Some people try and do it earlier. Like they'll go 2x plus 1 or plus 2 times 1 over. No, you can't do that. You have to put that all together first and get 3 to the something before you can set the exponents equal. Okay? So I add exponents on the top. I get 2x plus 3. So I have 2x plus 3 minus 8x minus 4. So what's 2x minus 8x? Negative 6x. And then I have a 3, because 2 plus 1 is 3, minus a minus 4. So what do I get? Plus 7. So it's going to be 2 plus 1, which is 3, minus a minus 4, which is 7. Remember, if you make an error, you can check you want to know how you... I'll do that in a second. I'm getting a little ahead. So we have 3 to the 6x plus 3. Now, the error where most of this happens is often this one to this one, correct? You can check every single step and see where you made an error. So you can type the original in and get an answer, correct? Then you could type your next step in and see if you get the same answer. If you do, you didn't make a mistake. You could type in your next step, see if you get an error or a different answer. If you don't, you didn't make a mistake. And type the next one in, you didn't make a mistake. Wherever the answer changes, you made the mistake, go back, fix that step. You know what I mean? You can check your steps. You can check every single time you do a solving. You could put in every single step, and you should get the same answer, right? You're just checking it, doing it in a different format. So if you ever make a mistake in a solving, you can y1, y2, y1, y2, y1, oh, this one doesn't match. There's where I made the error. Okay? You can check your errors. So now I have 3 to the exponent equals 3 to the exponent. Now I can set the exponents equal. Negative 6x plus 7 equals 6x plus 3. Add 6x. 7 equals 12x plus 3. Subtract 3, 4 equals 12x. Divide by 12. X equals 1/3. And every single one of them, this step, this step, this step, this step, this step, this step, they should all, if I y1, y2, get 1/3. Get 0.3333, right? And if they don't, then you go back and fix that step. Make sense? So you can actually like work your way through. Okay. I'm going to do number 4 next just because it follows the exponent thing. So there's the one where I can divide it over and I can convert to a log. Then there's the one where it's like you pray to Jesus and you're like, Jesus, please let this be a common base. And then he is great to you and he gives it to you. Correct? Yay. And then you go to 4 and you're like, okay, that can't be the common base. But that one's still way better than this one, right? But you could do this one log base 10 both sides and you wouldn't be wrong. You could go through and do the whole thing in log base 10 both sides. And I couldn't mark you wrong because it's the same thing. Okay. Number 4, we have 3, and then we have 4x plus 1 equals 5 to the 2x minus 1. Now, as opposed, I'm putting it underneath this one here. Do you see this? Difference between these two? This one I can divide the 3 over because that's a 7, and 7 divided by 3 isn't illegal. Right? It's totally fine. This 3, if I divide it over, I'm no better off because I'm going to be 5 to the 2x minus 1 over 3. And then I'm not sure what you're going to do from there. Now you just have a division with a log base 10. Right? So it's not going to join the 5 and it can't join the 4 because both of these have exponents. Do you see that? So that screams log base 10 both sides. That's what that does. If I took the 3 off and I have 2 exponents and 2 bases and I can't make a common base, I'd have to log base 10 both sides too. That's the other option, right? This is just the harder version because there's that one extra step. So I'm going to log base 10. I'm going to go log base 10 of 3, and then I aggressively put a large multiplication dot in here to try and remind myself I'm going to have to add them. It's going to separate by an addition sign. Equals log base 10 of 5 to the 2x minus 1. Now this I have to separate first. Some people want to drop the x plus 1 in front. You can't unless it's just by itself, right? So there's that extra step when you have the two things multiplied. You have to separate them by an addition. So we get log base 10. And if you can't do this immediately and know that's what I have to do, you won't get this right on the test. You'll forget that step and it will go badly. So you need to practice these until you know every step is what I do, what I do, what I do, what I do, right? If you're like, what do I do on the next one? You're not going to get the question right. Because you have nothing to look at to help your situation. Okay? So, once again, I could type that in, I could type this in, it would be the same answer. I could type the next one in, it should be the same answer. That's how I can check if I have errors, right? If you know your answer doesn't match what it should. So we get log base 10 of 3 plus log base 10 of 4 to the x plus 1. And the reason why I can do that is if I have a log base 10 of two things multiplied, I can separate them by an addition. We were taught that. And then I have this side log base 10 of 5 to the 2x minus 1. Then my exponents drop in front. Log base 10 of 3 plus x plus 1 log base 10 of 4 equals 2x minus 1 log base 10 of 5. and then I can distribute. If I didn't have this number in front, this 3 in front, I would immediately go to this one where I drop them in front, right? I wouldn't have to do the separation because there'd be nothing to separate. These 2 steps here wouldn't exist because I wouldn't have to have them. I could just log base, well, this one would, log base 10, and then I would go to here. I just wouldn't have to do the plus separation. Then I get log base 10 of 3 plus x log base 10 of 4 plus 1 log base 10 of 4 equals 2x log base 10 of 5 minus 1 log base 10 of 5. And then we're going to get the x's on the left. It's actually easier to move them to the other side. I'm going to show you what, if I'm a rebel and do the other side, what happens. So if I go log base 10 of 3, I'm moving the x's to the right because there's 2 logs on this side. Log base 10 of 4 plus log base 10 of 5. It doesn't matter if you move to the right or the left. Equals 2x log base 10 of 5 minus x log base 10 of 4. And I take the x's out. There will be a question like this on your test. You're like, I wonder if she's going to get, she will. She knows. She wrote the test. It will be there. Okay? Log base 10 of 3. I say that and then people still will like do one step and then get it wrong and then quit. It will not be in a multiple choice numeric response because you could just type it into your calculator. So don't bank on that either. It's not happening. And remember, because they're log base 10s, you can type them in without using the log base button. You can just type in log. And what do you get? X equals, pardon?
I don't know.
I'm going to trust you.
It's true.
2.2 what? 2.2. We have 2 more that I want to go through before you can start working on that booklet that's in front of you. The little, and by booklet I mean 3 pages. There's 2 other things. Yeah, sorry.
For that question,
Yeah.
I mean, I know that just makes it harder, but if you were to like put the 4 as instead of 4 like 2 to the power of 2x plus 2, like simplified it at the beginning, like that would just make it more complicated, but you'll still get the right answer, right?
Oh, yeah.
Okay.
If you just changed your base to something else. Yeah, totally. Okay. So we've solved ones. Oops, I forgot to do 3. 3. So we solved all the different exponent ones. So you see how I did different ones? I did one where you could move the 3 over and you could convert to a log because when there's 3 pieces, you can convert to a log. I did one where you had to do common base. I did one where you were stuck and you had to log base 10. We agree? Then there's 3 types of logs you could get. You could get the basic log, which is 3 log base 4 of 2x plus 1 equals 9. Whenever I have a single log, I know I'm converting to exponential. Now, how do I know? If the variable's here or the variable's in the base, I have to convert to exponential to get that variable out. Okay? Single log, you're going to convert to exponential. More than 1 log, you're still going to convert to exponential. You just have to do some work before you can get there. Okay? So right now I have 4 pieces of information. I can only have 3 pieces of information to convert to exponential. So I can divide by the 3, or I can bring the exponent up to 3 up here. Either way works. Like you can raise this 3 up here, or you can divide it over. If it divides over evenly, I'll choose that every single time. But you could raise it to the exponent by power rule. Now remember, what beside a log or beside a base is up with my exponent? It has to be what? Beside a log and in a base, what can't I not have? I can't have negatives. Can't I not? I really double negative there. I can't have a negative beside my log or in the base, correct? So a question they could ask you for is what are the restrictions, right? All you do is you take whatever's beside the log and you say it has to be greater than, nope, greater than 0, right? It just needs to be positive, correct? And if it was in the base, same thing. It would just have to be greater than 0. So if I want to state my restrictions, I go 2x plus 1 has to be greater than 0. 2x has to be greater than negative 1. X has to be greater than negative a half. When's the only time my inequality sign flips? When you divide by a negative. Other than that, you're just solving it like normal. So these would be my restrictions. If they ask restrictions, they're literally the easiest things to do. Don't forget to do them. Okay? If they ask for restrictions, you just take what's beside or in the base and set it greater than 0. Because you can't have a negative beside your log and in your base. So whenever you solve a log, you always have to make sure you check back and see that it's not extraneous. Right? Every single time. Every single time you solve a log, you have to check for extraneous roots. Okay. Now I don't know why I'm hugging this textbook. It feels comfortable. Okay. We convert to an exponential and we get, I'm just strengthening this arm. You don't know it. I'm bulking up. Okay. So base of my log becomes the base of my exponent. And then I get a 3. 2x plus 1. 4 to the 3 is 64. Equals 2x plus 1. Minus 1. 63 equals 2x. Divide by 2. And I get 31.5 equals x. Yeah. So if you take it, remember when you solve a log, you always have to plug it back and make sure it doesn't get you a negative beside or in the base. So I take 31.5 and I go 2 times 31.5 plus 1 is going to be a positive number. We're golden. If you do y1, y2, and you, no matter how many, and you have a standard window, and you go second trace 5, enter, 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 no matter how many times or how hard you press enter, it's going to tell you not happening. Okay? Because if your answer is 31.5, your x max has to be bigger than that in order to find it. So once you get your answer, make sure your x max is bigger than the number of your answer, and then you can go second trace 5, enter, 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 it'll find it every time. Okay? You just have to change your x max. Even if your y max isn't far enough, it doesn't matter, it'll still find it, as long as your x max is big enough. Okay, then there's two other logs. So there's the single log, where I can move it over or move it up to the exponent, and then I can solve it by converting to exponential. And then there's the other ones, where you can have logs in a number, or all just logs. Remember, that was our second last lesson, so we're going to solve those ones. And I'm going to actually go in here and not make it up, because I don't want it to be terrible. Okay. So this would be 5. Log base 3 of 2x minus 1 equals 2 minus log base 3 of x plus 1. When I read two log base 3's, what do they scream to me? Put me together. But they're on opposite sides. So can we put them together currently? No. So we're going to have to move them to the same side, then put me together. Okay? Once they're together, you have a single log, just like the last question. Convert to exponential. That's it. So not crazy. Okay? That's number 5. Then number 6. Number 5, you can solve two different ways, and I'll show you both. When they're all logs, you can put them together on one side, put them together on the other side, set what's beside your logs equal. Or you can move them all to one side, set it equal to 0, put them together, and convert to exponential. Okay? So try these two.
They're just messing around.
Okay, why did I put these together as a multiplication? Shh. Why did I put them together as a multiplication? No, why did I put it together as a multiplication? Like, how come? Yeah, because this has a plus 1 in front of the log, and this has a plus 1 in front of the log. Shh. If this had a plus 1, quiet please, the 2x minus 1 would be on the top. If it had a minus 1 here, the x plus 1 would be on the bottom, right? And then you would still convert, but you'd have a fraction. And you have to take that bottom up. Okay, So once we're here, we go 3 squared equals 2x squared minus x plus 2x is plus x minus 1. And then I get 0 equals 2x squared plus x minus 10. Right. So I'm going to get 2x squared. What multiplies to me 20 and adds to give me x is going to be plus 5x minus 4x. So minus 4x plus 5x minus 10 equals 0. Take a 2x out, I'm left with x minus 2. Take out a plus 5, I'm left with x minus 2. 2x plus 5, x minus 2. I get x equals negative 5 over 2, or negative 2.5, and I can put that because it terminates, and then x equals 2. So I take the 2 and I go, 2 times 2 is 4 minus 1 is 3. Can I have a 3 beside my log? Yeah, 3 is fine. It just needs to be a positive number, right? Then I go 2 plus 1 is 3. Can I have a 3 beside my log? Yeah. But you could also type it in and see if it equals left side equals right side, right? You can do that as well. So this one's golden. I take negative 2.5. So 2 times negative 2.5 is negative 5 minus 1 is negative 6. Can I have a negative 6 beside my log? No, this one's immediately done. So I circle it, put a line through it, say extraneous. Now, I didn't state the restrictions, but there are variables in here, so I should state restrictions. So I say 2x minus 1 has to be greater than 0, and I say x plus 1 has to be greater than 0. So this one's going to be 2x is greater than 1, x is greater than a half, and then this one's going to be x is greater than negative 1. Now we have to pick the one that actually encompasses. We could take the one that encompasses both if we can. So it has to be greater than negative 1 and greater than a half. I could just leave both. Yeah.
On the test, would we have to have restrictions if it doesn't ask for it or only for that?
Only if it asks for it. It's better, only if it asks for it. On a diploma, often they'll ask them separate. Like they'll say solve this and state the restrictions. Because neither of them like really counteract each other. Like if you solve wrong, it doesn't mean you can get your restrictions wrong, right? Like you don't need either of them to do it. So when they do parts of questions, you always have to have them not, one can't like mess up the other one, right? So they can do A, which is a restriction, and then B, which is a solving, or they could do A, which is a solving, B, which is a restriction, because they don't affect each other. They won't often ask it together. They could. Okay. So x, you can leave these separately, but x is greater than negative 1 actually covers that one already, doesn't it? So I could just state x is greater than negative 1, and it would actually encompass this one as well, because a half is greater than negative 1. I could just state the 1. Or I could leave both. But if it was a multiple choice, they're only going to give x is greater than negative 1, because a half also falls in there. If you don't know what I'm saying, here would be negative 1, here would be a half. So if it's greater than a half, that's this way. If it's greater than negative 1, that's all of this, which encompasses this part, correct? So I don't have to state that piece, because the greater than negative 1 covers it. It's okay if you state both if it's a written response, but in multiple choice it won't have both. It'll just have the negative 1 because it takes into account the half already. Okay, 6. There's no way I would want to bring these together. You could bring them together. I'll do both. It's optional. I'll do both just so you see. I would never bring them together if they're all multiplied, because now you have a cubic and you have to do synthetic division. I would question myself if that was the case. This one you won't have to, because you're going to subtract one of them, so it'll end up in the denominator. But I'll do both. I'll do the one that you guys probably picked, which is log base 7 of x plus log base 7 of x minus 1 minus log base 7 of 4x. And then what's left on this side? 0. So I would get log base 7. X would go in the numerator because there's a plus 1 in front. What if there's not plus 1s or minus 1s in front? What do you have to do first? Take the number raised to the exponent, correct? So we're going to get x minus 1, and then on the bottom we have a 4x, and it equals 0. Now I have a single log. What do I do when I have a single log? Convert to exponential every single time. So all these ones is one extra step to get it to be a single log to convert to exponential. That's all they are. So now I get 7 to the 0 equals that. 7 to the 0 equals x squared minus x over 4x. What's 7 to the 0? 1. What do I do when I have something now sitting like this? People get stuck at this step. multiplied by the 4x, I think is what was. You could technically take one out, but if you take one out, you're getting rid of, you could be getting rid of a solution. It's just like on the, not going to speak. Andre has not written it. Shh. Multiply by 4x. Going to stop talking. I would have given an n. It would have been a problem. So now we have 4x equals x squared minus x. And then 0 equals x squared minus 5x. And then what can I do? When you're stuck 97% of the time, all you guys are going to pop this into the quadratic formula, which is terrible. G, C, F. The C is 0. I have seen people do it. It's a scary place. Don't do that. Just take out a GCF. Yeah, you can put a C and a 0 into the quadratic formula. It'll still get the same answer. It's just long. So this is x equals 0, and this is x equals 5. Now remember I told you have to have a positive beside your log? Let's go 0 and 5. If I put a 0 in here, I have a 0. Am I allowed to have a 0 beside my log? Nah, it's out. Okay, and the other one was 5. This will get me 5. That's fine. 5 minus 1 is 4. That's fine. 4 times 5 is 20. That's fine. Now, sometimes they're both extraneous. Sometimes there's no answers. Sometimes they're both answers. Sometimes one's not an answer. Make sense? So this one, extraneous. This one's good. Now, Mrs. Lepp wouldn't have done it this way. Do you see the work involved? Do you see how long that was? Okay. If they're all logs, I will just put left side together, right side together. So I'll go log base 7 of x times x minus 1 equals log base 7 of 4x. And then I'll go log base 7 of x squared minus x equals log base 7 of 4x. Log base 7 of this equals log base 7 of this, so those equal. We did it in the notes. And I gave you a homework question, told you to do this that way. I didn't guess that at all.
Oh, wait.
You could have gotten around it and done it that way, but I told you guys to try it like that. Substantially shorter this way. Okay, ready for a big kahuna question? What if I give you this? I said I have one more I want to do because I forgot about it. Log base 2 of log base 3 of log base 2 of x plus 1 equals what? Easy question if you know how to do it. If you don't know how to do it, really, you'll just stare at it for a long time. If I actually cover up these brackets in here, this is a single log. If I cover up this part,
But you can't just erase part of it.
I'm not asking you to. If we pretend that that's one thing, it's a single log. So we would go 2 to the 1 equals the blue dot.
Oh, okay.
Every time you have a log embedded in a log, you're going to have to switch it to exponential that many times. So how many logs do I have embedded? 3. Technically, I have a log, and a log. So I'm going to have to convert to exponential 3 times. So I treat this dotted line as if it's just what's beside my log, correct? And I work from outside in. So I'm going to go base my log to 1 equals what's beside it. That's my first step. I work from outside in. So I'm going to go 2 to the 1 equals the dashed line. Log base 3 of log base 2 x plus 1. So now I have 2 equals log base 3 of log base 2 x plus 1. Now I treat this like the inside of my log. How would I convert it? 3 to the 2 equals the dashed line. Do you see I'm working myself into the log? So it's 3 to the 2 equals log base 2 of x plus 1. So now I have 9 equals log base 2. So I've converted twice. I know I'm going to have to convert a third time. However many logs are embedded is how many times you have to convert. So I've converted twice, and now I have a nice one. Now this is just a single log. 2 to the 9 equals x plus 1 minus 1. 2 to the 9 minus 1 equals x. And I don't know. Really large number. 511. If you want to check this from the original, your x max is going to be 512, or you're not. It's second trace 5, enter, enter, enter. No matter how hard you hit it, is not getting you the answer. Okay? You to try. Yep, because I'm not helping you this time. Try that one out. So this one, you're going to get 2 to the 1 equals log base 2 of log base 3 of 2x minus 1. Quiet, please. And then I get 2 to the 2 equals log base 3, guys. 2x minus 1. Then I get 3 to the 4 equals 2x minus 1. It's an aggressive 2. 3 to the 4 is 81 plus 1 equals 2x. 82 equals 2x. X equals 41. Okay, what if I give you this? Told you I'm going to give you a couple extras. What if I give you this? Ready? I want this all put together. I want you to simplify as one log. Ready? Bless you. So simplify as one log. Log 2 log base 6 of, let's say, x minus 3 log base 6 of y plus 4. One log. One log. Your AP. Use your big brains. Let's do a little discussion. I can only put logs together that have what? Same base, and what's in front of them? Okay, everyone knows that. Most people can get to this point. What do I have to do to the first one? Square it. What about this one? Cube it. And then people sit for a long time.
4.
I need the 4 to be a base what in order to put it together? Okay, we know that. I need it to be log base 6 of something equal to 4, because I need it to equal 4. Like, I don't want to write it equal to 4. I just need this to somehow be 4, right? What can I do? Yep. Close. Nope. 6 to the 4. Exactly. It has to be 6 to the 4. Why? Because when you have two base, the base and the number beside that are the same, the answer is the exponent, isn't it? So you can take that exponent and drop it in front. Oh my gosh, in front. Log base 6 of 6. I'm quitting. It's period 1 and I'm quitting. All right. So we have log base 6 of x squared minus log base 6 of y cubed plus log base 6 of 6 to the 4. Because 6 to the 6 to the 4 is 4. A to the A to the B is B. Because that 4, we don't want to do this. We don't want to drop it in front. But if I drop the 4 in front, it'd be 4 times log base 6 of 6. And what's log base 6 of 6? 1. And 4 times 1 is 4. So that's why, because this 4 can drop in front. So whenever this and this are the same, the exponent is your answer. And now we can actually put them together. Log base 6. Now some people will be like, oh, that's 4. And they put it back to a 4. And I'm like, undid your problem. You will do it. You'll be like, I know the answer. I'm like, yeah, you just made it. So, we get x squared on the top because there's a plus 1 in front. We get y cubed in the bottom because there's a minus 1 in front. And we get a 6 to the 4 on the top. I don't know what 6 to the 4 is. Help me.
Big number.
Wow.
Point 0? Yeah, we're not going to do that.
Yeah. Based on the P of this.
I got one more. Another challenger, big brains. We need our big brains. You can pick out whatever paper you want. I'm not making you put it on one piece of paper.
Just write over what you've already done.
And force this on one sheet. I don't know how this is. Must do on one paper. Okay. Log base A of so sweet. 48 A cubed when. So I want you to determine the value, or actually just simplify this, when log base A of 4 equals B, and log base A of 3 equals M. What do I do when I have a log and two things multiplied by side? Split them apart and put a really big multiplication symbol so I remind myself I can split them. If not, people will keep the 48 and the A side by side, right? They'll like attach them. But they're not attached. They're multiplied. That's great. I'm not going to separate them right now, though, because I have on the side log base A of 4 and log base A of 3, which is lovely. If I have a 4 and a 3, I can fill in a B and an M. Great. I have a 48. Royally sucks. But it doesn't, actually. 48 could be broken into those, can it? 9 times 4 is lovely, but we need 4s and 3s. Keep going. And 9 times 4 is 36, which is also lovely, not 48. 8 times 6 is also lovely, but I need 4s and 3s. Yes, keep going.
4 times 3.
Times 3. We need to break it. We got there. We got there eventually. We went the long route, but we got there. 4 times 4 times 3 is 48. Remember, I go and I look at the logs that I gave you. The logs I gave you were 4s and 3s, so you can break it into any other version you want, but you're not getting any closer to the problem. Okay? So 48 is 4 times 4 times 3. You have to break it into what I gave you. See how that worked? Good. You got there. Yes. 8 times 6 is lovely, but useless. Okay. So we go 4 times 4 times 3 times A cubed. Now, even if you get past this point, people will make mistakes, so watch out. We have 4 times 4 times 3 times A cubed. What am I going to have to do now? What? Split them up by addition. Log A of 4 plus log A of 4 plus log A of 3 plus log A of A cubed. What can I do with this 3 in front? Put it in front. Okay. What is log A of 4? Plus 3 times technically 1, which is 3. So now I get 2b plus m plus 3. Done. Well, I'm not moving. It's still sitting here. Okay. For your homework is to work on the sheet in front of your face. I have a new one for tomorrow. Oh.
I thought we did 5.